let's come on to the next part of the chapter, that is called as resistivity. Okay, now first let us understand what do we mean by the, or why did this concept come out, that is of resistivity. Okay, now few cases I have just kept on the screen. That is, this is the first circuit which is made from, let's say, copper wire. This is the first circuit that is made from, let's say, copper wire. So this is my CU. Second circuit, which is again made up of copper wire, and the below two circuits are made up of aluminium. Okay. Now, since they are two different substances, I know that their resistances will be different. Okay, that is okay. That is fine. Now, what happened was the student was given an activity to make a simple circuit. Okay, very simple circuit. That is, एक bulb लेना था, एक battery लेना था, and he had to just make the bulb glow. Okay. Now, what he did was, in the first case, he took up some wires. Let's say ये वाला wires लिया, and let's say just assume करते हैं कि ये वाले का length था 1 meters. Okay, bulb थोड़ा सा glow हुआ. Okay. Next time he tried to repeat the experiment, but he took a longer wire. ठीक है, experiment तो same ही था, but he took a longer wire. Now, if he is taking the longer wire, what is the problem over here? ठीक है, हम लोग जब अभी तक देख रहे थे, we used to take the resistance only of the object. या तो बल्ब का रेजिस्टेंस लेते थे, और या तो जो ऑब्जेक्ट रहता था उसका रेजिस्टेंस लेते थे, वो R1 R2 वाला पार्ट. बट इन प्रैक्टिकल लाइफ ये जो वायर्स है, ये वायर्स का भी तो रेजिस्टेंस होगा, बराबर है. इसका भी रेजिस्टेंस होगा, इसका भी रेजिस्टेंस होगा, इसका भी रेजिस्टेंस होगा, इसका भी रेजिस्टेंस होगा. Okay, so what he did was he tried to get some logic of what exactly or how exactly is the bulb glowing. Okay, so let's say in the first case, he saw that the intensity of the bulb was better as compared to the wire when he is taking longer lengths. Let's say in this case, he took a 1 meter length, and here he took a wire of 2 meters ka length. The wire length over here is, let's say, 2 meters, versus when he took a 1 meter length wire, he observed that the intensity of the bulb glowing is very good as compared to that of second. अब ये क्यों हुआ? Because यहाँ पे length of the conducting material, that is the length of the wire, increased. ठीक है, copper का length in this case is more than the copper length of the first case. ठीक है, भले ही ये दोनों वायर्स ही है, तो इनका भी तो रेजिस्टेंस होगा खुद का, तो इसका रेजिस्टेंस बढ़ गया और इसका रेजिस्टेंस कम हो गया. Okay, so what he observed was, when I'm taking a wire of shorter length, the bulb is glowing much more as compared to that of the second one. Okay, अब उसने क्या किया? He repeated the experiment. He repeated the experiment while taking aluminium. उसने material change कर दिया, aluminium ले लिया. Okay, let's say जो length उसने लिया वो 2 meters नहीं लिया, but let's say 1.5 meters ले लिया. Just for an example, he is taking it as 1.5. Now the intensity that he saw was in between 1 and 2. यहाँ पे let's say the intensity of the light was between the first and the second case. Between first and second इसका intensity था, बराबर. Now what he did was, in the last case, he took a thicker aluminium wire. अब उसको मस्ती सूझा, उसने thick aluminium wire लिया, and he repeated the experiment. To his surprise, what he found was a thicker aluminium wire, but of shorter length. Let's say of the length of the wire is over here 0.5 meters. I'm just taking a random examples and giving you random examples. So he took a thicker wire, but shorter length, and he found out that the copper wire, which the brightness of the lamps are same. When I'm using a thicker aluminum wire versus with a shorter length versus a normal copper wire with 1 meter ka length and a thicker aluminum wire with 0.5 meters length, is getting the same intensity of the bulb. Okay, now the question over here is, वो क्या करे? Should he use a shorter length aluminum wire and not use a copper wire, or he should use 1 meter का copper wire and not aluminum wire? बराबर. उसको मिला क्या था यहाँ पे? ये केस में और ये केस में उसको इंटेंसिटी मतलब जो ब्राइटनेस फर्स्ट बल्ब दे रहा था उतना ही ब्राइटनेस सेकंड बल्ब दे रहा है. ओके, so he found that both of them were same. So now what to do? Now he could not answer that question. बराबर. फर्स्ट सेकंड में तो उसको मिल गया, फर्स्ट थर्ड में भी उसको ये जो मेरा थर्ड केस है सपोज, यहाँ पे भी उसको आंसर मिल गया, यहाँ पे भी उसको आंसर मिल गया, लेकिन इन दोनों में नाउ ही कैन नॉट डिसाइड कि मैं क्या करूं. ठीक है. एंड सपोज ही सेज दैट कि नहीं मैं 0.5 मीटर्स का एल्यूमिनियम लूंगा. बराबर. और ये तो छोटा सा एक्सपेरिमेंट है. अगर घर पे ये करने को बोला और अगर वो एल्यूमिनियम का वायर जितना चाहिए था उतना उससे ज्यादा अगर मेरे को लग गया तो वापिस बल्ब का इंटेंसिटी चेंज हो जाएगा. Why? Because the resistance is changing. The resistance is changing because of two perspectives. रेजिस्टेंस यहाँ पे चेंज क्यों हो रहा है? रेजिस्टेंस इज चेंजिंग बिकॉज ऑफ द लेंथ. जो हमने पहले देखा था दैट रेजिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू द लेंथ एंड इनवर्सली प्रोपोर्शनल टू द एरिया. बराबर. तो अब यहाँ पे क्या हुआ था ये वाले केस में, सिंस द एरिया इज मोर द रेजिस्टेंस डिक्रीजेस and since the length is more again the resistance decreases. That's why aluminum and copper का same answer मिला उसको. So now what to do? Should he take aluminum? Should he take copper? ठीक है, cost wise almost दोनों equally हो जाएगा, इतना कुछ ज्यादा फर्क नहीं पड़ेगा. So to answer this question that whether I should use copper and whether I should use aluminum is very difficult using the concept of resistance. क्योंकि क्या होगा, समझो अगर गलती से भी ये 1 मीटर का वायर 1.5 मीटर्स हो गया, ये वाला 1 मीटर का वायर अगर 1.5 मीटर्स हो गया, रेजिस्टेंस चेंज हो जाएगा. रेजिस्टेंस जैसे ही चेंज हुआ ये बल्ब पे अफेक्ट पड़ेगा बिकॉज द सर्किट का रेजिस्टेंस इज चेंजिंग. ओके, so this is a very big problem that the length and the area are determining the intensity of the particular bulb. Hence, while taking a decision that I should use which wire and of what thickness while designing a household circuit, ये तो छोटा सा सर्किट था, लेकिन एक हाउसहोल्ड सर्किट का मुझे अगर डिसीजन लेना पड़े तो रेजिस्टेंस विल नेवर गिव मी अ परफेक्ट आंसर बिकॉज लेंथ एंड एरिया चेंज हो रहा है और मेरा रेजिस्टेंस चेंज हुए जा रहा है. ओके, so then what should be the criteria? The criteria should not be resistance because ये जो दो चीज है उसकी वजह से इस पे हमारा कंट्रोल ही नहीं है. ये दो चीज पे हमारा कंट्रोल ही नहीं है. Why? Because कभी भी मुझे अगर हाउस होल्ड सर्किट बनाना हो, लेंथ ऑफ द वायर कभी भी इंक्रीज हो जाएगा. ठीक है, आई मे नॉट गेट द सेम थिकनेस ऑफ वायर एवरी टाइम, दैट इज ऑल्सो पॉसिबल. थोड़ा सा आगे पीछे मिले, हो सकता है. Hence, a new concept comes in that is called as resistivity, which does not depend upon the length and the area of the material. ठीक है, तो मतलब चाहे कोई भी लेंथ का वायर लो, चाहे कोई भी थिकनेस का वायर लो, resistivity will not depend upon it. ठीक है, now see how resistivity comes into picture. ठीक है, this is a very good example. Okay, so let's see the resistance का फंडा. So resistance का हमने क्या बोला था? Resistance is directly proportional to the length and inversely proportional to the area. okay, that we had seen in the 4 factors. तो हम क्या करेंगे, ये proportionality sign हटा के we will introduce a concept that is called as rho. Rho is nothing but called as constant of resistivity or coefficient of resistivity. It is the coefficient of resistivity. So the formula becomes R is equals to rho L upon A. Okay, so if I want to say the what is the formula for rho, rho is nothing but R A upon L, and the SI units of rho will be equals to resistance is measured in terms of ohms, area in terms of meter square, and length in terms of meters. Meter cancel, so rho का SI unit is nothing but ohm meters. Okay, now see how this resistivity helps me. ठीक है, ये देखो अभी मेरे हेल्प कैसा करेगा. हमने क्या बोला, let's say the length of the wire is, let's say length of the wire is 10 meters. अगर length of the wire is 10 meters, तो resistance उसका जो है वो हो जाएगा, just for an example 5 ohms. मतलब 10 मीटर के वायर का resistance is 5 ohms. उसको L1 ले लेते हैं और इसको R1 ले लेते हैं. So if the length becomes, L2 becomes, let's say 20 meters, then I know that R2 will become, R2 will be equal to double, that is 40, because the length is doubling, the resistance will also double. R is directly proportional to the length. Okay, now let's say I take a thickness of wire E1, which is equals to, just for an example, 5 meters, 5 meters square. And if this is 5 meters square, then just a random example, R1 will be equal to, this is a new example, okay, not connected to the first one. If the thickness of the wire is 5 meters square, then its resistance is, let's say, 10 ohms. And if I reduce the thickness, or let's say if I double the thickness, I make it 10 meters square, then the resistance R2 will become 5 ohms. Why 5 ohms? Because as the area increases, resistance decreases. Area double हो गया तो resistance half हो जाएगा. Okay, ये example समझा? यहाँ पे length double, so the resistance double because resistance is directly proportional to the length. And second case में area double, so the resistance is half. ठीक है, अब एक केस देखते हैं जहां पे दोनों चीज हो जाए. That is L1 जो है, L1 का वैल्यू पहले था 10 मीटर्स एंड तभी A1 का वैल्यू था लेट्स से 5 मीटर स्क्वायर. ठीक है, यहाँ पे मैं लिख देता हूं, लेंथ डबल हो गया तो एरिया, रेजिस्टेंस जो है वो भी डबल हो गया. यहाँ पे एरिया डबल हो गया, so the resistance became half of the original resistance. ठीक है, मतलब if the length is double, so I say L2 is 2 times L1, R2 is 2 times R1, A2 is 2 times A1, so therefore R2 is half times R1. Now I am doing two things together. ठीक है, अब ये चीज याद रखना, अगर ये डबल हो रहा है तो रेजिस्टेंस भी डबल, और ये डबल हो रहा है तो रेजिस्टेंस हाफ, रेसिप्रोकल होएगा इसका. Okay, now what I am doing is L1 is 10, R1 is 5. In this case, the value of R1 is, just for an example, 50 ohms. Okay, it is nothing but 50 ohms. Now, let's say what I do is I triple the length. Now see over here what happens. I triple the length. So the length is now 30 meters. I triple the length. This is now 30 meters, and I make the area 4 times, मतलब ये 5 का I make it 20 meters square. मतलब मैंने thickness को 4 times कर दिया and length को 3 times कर दिया. Now just understand what will be the value of R2 in this case? ठीक है, अब यहाँ पे देखो, यहाँ पे हमने क्या देखा था कि अगर लेंथ डबल हो गया तो रेजिस्टेंस इज ऑल्सो डबल्ड, एंड इफ द एरिया इज डबल्ड रेजिस्टेंस बिकम हाफ, दैट इज द रेसिप्रोकल। तो यहाँ पे क्या होगा, लेंथ ट्रिपल हुआ है तो इसकी वजह से, लेंथ ट्रिपल होने की वजह से R2 will be triple times of the original resistance, that is R1, but A1 has become 4 times, ठीक है, A1 has become 4 times, or sorry, A2 has become 4 times of A1, and L2 has become 3 times of L1. So the resistance will be 3 times of R1 because of, it will be 3 times of the original, the resistance will be 3 times of the original resistance because the length has been tripled, but the resistance will also be 1/4 of the original resistance because it will be 1/4 of the original resistance at the same time because the area has been made 4 times. ये double effect है, 3 times लेंथ की वजह से एरिया रेजिस्टेंस ट्रिपल हो गया, एंड एरिया की वजह से वो 4 टाइम्स कम भी हो जाएगा, तो यहाँ पे डबल इफेक्ट क्या आएगा, द रेजिस्टेंस बिकम्स 3/4 टाइम्स द ओरिजिनल रेजिस्टेंस, 3 times because of the length, and 1/4 because of the increase in the area. Increase in area हुआ तो resistance becomes 1/4 of the original resistance. Okay, getting this part? ये समझा इतना? Now let us go ahead. अब हम क्या करेंगे, हम दोनों केस में ना रेजिस्टिविटी की वैल्यूज निकालते हैं. Let's calculate the values of resistivity in both case. So rho 1 is equals to RA upon L, so that is 50 into, I'll use this formula, 50 into A का value is 5. So 50 into 5 upon 10, 0, 0 cut. So I get the value of rho 1 as nothing but 25 ohm meters. Let's calculate the value of rho 2. Rho 2 is nothing but equals to 3/4. R1 का R2 का value is 3/4 times multiplied by the original resistance. R1 का value is 50. So into 50 into A1 का value is 20 divided by L का value is 30. Let's calculate 0, 0 cut, 3, 3 cut, 2 1s are 2 2s are, and 2 1s are 2 25s are. So I get this answer as 25. So again, see what is the value of rho 2? Rho 2 became 25 ohm meters. अभी मैंने क्या किया है यहाँ पे, see you check this, रो का वैल्यू चेंज नहीं हुआ, you triple the length, you made the area 4 times, resistance change हुआ लेकिन रो का वैल्यू चेंज नहीं हुआ. That means any material of any length, what does this mean? You have any material of any length of any thickness, ठीक है, you have any material of any length or any thickness, any length, any area, इसका क्या सेम रहेगा, इसका रेजिस्टिविटी सेम रहेगा, रो रिमेन्स द सेम फॉर एनी मटेरियल. ठीक है, मतलब यहाँ पे सी डिसीजन मेकिंग इजी कैसा हो जाता है, डिसीजन मेकिंग इजी ये हो जाता है कि अगर मुझे ये सर्किट बनाना है तो आई विल नॉट लुक एट द रेजिस्टेंस ऑफ द वायर, I will always check the resistivity of copper and aluminium. This becomes easier for me to compare. If the resistivity of copper is better than the resistivity of aluminium, my job is done. But if the resistivity, or if the resistance is compared, resistance में मेरे को यहाँ पे same value आ रहा था, but यहाँ पे ऐसा नहीं होगा. ओके, बिकॉज एक मटेरियल का कोई भी एक लेंथ और कोई भी एक एरिया अगर मैं पकड़ूं, मतलब एक थिकनेस पकड़ूं, तो उसका रेजिस्टिविटी रिमेन्स द सेम. ठीक है. नाउ व्हाट डज रेजिस्टिविटी डिपेंड अपॉन? रेजिस्टिविटी ओनली डिपेंड्स अपॉन टू फैक्टर्स. फैक्टर्स अफेक्टिंग रेजिस्टेंस, तो यहाँ पे सॉरी, फैक्टर्स अफेक्टिंग रेजिस्टिविटी. सो व्हाट यू हैव टू डू ओवर हियर इज, पहला दो पॉइंट ऑफ रेजिस्टेंस वो निकाल दो. सो दैट इज नेचर ऑफ मटेरियल, इस पे डिपेंड करता है. मतलब कॉपर का रेजिस्टिविटी अलग होगा, एल्यूमिनियम का रेजिस्टिविटी अलग होगा. सो इट डिपेंड्स अपॉन द नेचर ऑफ मटेरियल, एंड सेकंड इट डिपेंड्स अपॉन द टेम्परेचर ऑफ द कंडक्टर. Now let us understand why does it depend upon the temperature. So there are only two factors which affect resistivity. One is the nature of material and second is the temperature. अब क्या होगा, let's say temperature, why I am saying temperature में, because temperature changes the resistance. ठीक है, यहाँ पे हमने सिर्फ उसका लेंथ एरिया को पिक्चर से निकाला है, बट सपोज टेम्परेचर ऑफ द मटेरियल चेंजेस. अगर टेम्परेचर चेंज हो गया, सो रो का फॉर्मूला दैट इज रो इज इक्वल्स टू RA अपॉन L. सो इफ द वैल्यू ऑफ रेजिस्टेंस इंक्रीजेस, अगर रेजिस्टेंस इंक्रीज हो जाएगा, सो दैट मीन्स रो का भी वैल्यू इंक्रीज हो जाएगा, बिकॉज रेजिस्टेंस इंक्रीजेस, रेजिस्टिविटी ऑल्सो इंक्रीजेस. इट इज डायरेक्टली प्रोपोर्शनल. ओके, नाउ टेक्स्ट बुक में ना इसका डेफिनेशन कुछ थोड़ा सा अलग दिया हुआ है, दैट इज एसचान में. दैट इज हाउ डू दे राइट द डेफिनेशन ऑफ रेजिस्टिविटी इज, resistivity is defined as, I'll just write that, resistivity is defined as the resistance of the material of unit length and unit area of cross section. Resistivity is defined as the resistance of the material of unit length and unit area of cross section. अब इसका मतलब क्या होता है? इसका मतलब एकदम सिंपल है, that if ये फॉर्मूला में, अगर ये फॉर्मूला में if I substitute the value of A equals 1, that is unit area, and if I substitute the value of L as 1, तो क्या होगा? यूनिट लेंथ मतलब लेंथ 1 एंड यूनिट एरिया मींस एरिया 1. तो इसका आंसर क्या आएगा? रो इज नथिंग बट इक्वल्स टू आर, क्योंकि इसका भी वैल्यू 1 आ गया और इसका भी वैल्यू 1 आ गया. सो रो इज नथिंग बट इक्वल्स टू आर. So hence they say resistivity is defined as resistance of the material of unit length and unit area of cross section. Okay, now next topic is heating effect of the current. ठीक है. Now what do I mean by heating effect of the current is, let's say there are many applications of the heating effect in our normal day life that we don't even do know. That is, we have toasters, geysers, then we have electric irons. All those come under this particular topic, that is heating effect of electric current. Okay, now what is this topic all about? First, we understand it that whenever a current is passing through a resistance, that is any conductor, it always gets heated up. ठीक है. समटाइम्स देखो, तुम्हारा मोबाइल जब चार्ज होते रहता है, समटाइम्स यू सडनली फील दैट द मोबाइल हैज सडनली रेडिएटिंग हीट. ठीक है, सडनली गिविंग आउट हीट. सो व्हाई डज इट गेट हॉट? Okay, that is only and only why is the heating effect taking place is because of collisions. Collisions किसका? Collisions of the electron. ये किसकी वजह से होता है? It happens due to the collision of electrons with the neighboring atoms, that is with the neighboring nucleus, maybe, or maybe with the neighboring electrons also. There may not be electrons, but at least they will strike with the neighboring atoms. And when they strike, they produce heat because there is a friction which is created. Okay, so heating effect takes place because of it. Now there is a formula for heating effect that we have to derive, तो वो एक एक करके derive करते हैं, ठीक है? So we start with the definition of the potential difference, that is potential difference V is equals to W upon Q, याद है? Work upon charge. Okay, so what I can say that work is nothing but equals to W into Q. Okay, getting this part? Now, what do you mean by this? Work done. And what was this work done? Work was done in this potential difference, that was to move a charge from one point to another point in a circuit. मतलब अगर ये circuit है मेरा, ये मेरा, if this is my circuit, what work I have to do? I have to do a work. Let's say this is my battery. I had to do work to take an electron from one point to another point in the circuit. Okay, so that is nothing but the work done, and we know that work done is nothing but energy. Last year pada hai, work is nothing but energy. So I can say that the energy, or the electrical energy, to be specific in this particular example, because chemical energy is converted into electrical energy, so I say that electrical energy is nothing but equals to W into Q. Okay, we had also seen the formula for current, that is I is equals to Q upon T. From this, what I can say, Q is nothing but equals to I into T. I substitute the value of Q in this equation, and what I get is V is equals to I into T. Q की जगह पे I substituted I into T. Getting this part? Now, I know that potential difference V is equals to I times R, Vir. So I can say that V, or if I substitute the value of V in this equation, now I can say that E is nothing but equals to IR into T. So that is nothing but equals to I square R into T. And see, this is nothing but the electrical energy. And what I told you was, let's say if I consider this as an electric ion, okay, if I consider this as an electric ion, तो ये जो एनर्जी मैं प्रोवाइड कर रहा हूँ विद द हेल्प ऑफ द सोर्स, बैटरी तो नहीं होगा, जैसे वो घर से उनको इलेक्ट्रिसिटी मिलता है, तो द इलेक्ट्रिसिटी विच आई एम अप्लाइंग इज यूज्ड फॉर व्हाट? दैट एनर्जी. यहाँ पे केमिकल एनर्जी था जो इलेक्ट्रिकल में कन्वर्ट हो गया, और ये इलेक्ट्रिक एनर्जी जो है दैट इज यूज्ड अप बाय द इलेक्ट्रिक आयन टू हीट इटसेल्फ. तो इसको मैं क्या बोलूंगा? दिस इज नथिंग बट द हीट एनर्जी, जिसको मैं H से रिप्रेजेंट करता हूं. एंड दिस फॉर्मूला, दैट इज H इज इक्वल्स टू I स्क्वायर RT, is also called as Joule's law of heating. Okay, now what does this law say is that the heating effect inside any device, that is iron or toasters or geysers, is dependent upon three things. Okay, the law says that the heating effect because of electric current is dependent upon three things. First, it is dependent upon, that is the heating effect is dependent on the first thing, that is square of the current. Second, it is dependent upon the resistance of the material and time for which current flows. Okay, so what does this Joule's law say? Joule's law says that the heating effect depends upon three things, that is the square of the current, that is I square, resistance of the material, that is R, and the time for which the current flows, that is T. अगर समझो current flowing is more, the heating effect produced by the device will be more. इसके लिए याद रखो जब भी electric ions हम on रखते हैं, अब उसमें वो continuously heat नहीं देता है, it is always a on off mode, so that the current which is produced is not much. ठीक है, that is a concept of fuse. We will see it in the next chapter. Okay, resistance, अगर कोई material का resistance high है, if the material has a higher resistance, that means it will produce more heat. High resistance मतलब वो conductor है, इसके लिए electricity conduct करेगा, but since resistance is high, the collisions will be higher, and since the collisions are higher, the heating effect produced is more. And third, time taken अगर ज़्यादा है, so that means you are passing the current for a longer period of time, and since you are passing the current for a longer period of time, that means more striking of electrons. More striking of electrons means the heating effect that is produced is more. Getting this part? So these are the three things on which the heating effect depends upon. What are the practical applications of heating effect? ठीक है, अब इसके practical applications क्या है, ये सब तो हमने अभी देख लिया. और how is the heating effect practically used up as? इसका common example is bulb में there is always a tungsten filament that is present. कोई भी अगर मेरा bulb रहेगा, ठीक है, let's say ये मेरा bulb है, तो inside if you observe there is a wire. अभी तो सब वो LED bulbs और ये सब आते हैं. This is I'm talking about the older bulbs which used to come. So inside you used to have a tungsten filament. This is made up of tungsten. Okay. Now the property of tungsten is when the current is passed through it, the heat which is produced, because of the heat produced, it starts glowing. ठीक है, जैसे ही इलेक्ट्रॉन्स उसमें फ्लो होंगे, द डिवाइस गेट्स हीटेड अप. एज इट गेट्स हीटेड अप, और लेट्स से इवन द एग्जांपल इज ऑफ फ्लड लाइट्स में भी यही कंसेप्ट होता है कि वो थोड़ी देर के बाद वो एकदम ब्राइट हो जाता है. ठीक है, मतलब आफ्टर सम पॉइंट ऑफ टाइम व्हेन लॉट ऑफ करंट फ्लोज इन, द flowing of the current makes the tungsten filament very very hot, and once it makes it very very hot, it starts glowing. ठीक है, मतलब it gives more brightness. Now only thing that you have to remember is in this tungsten ka melting point is very high, so it may be about 3000 wala. So it melts at a very very high temperature. So easily by the passage of current वो melt नहीं होएगा. मतलब अगर ये melt हो जाता suppose, तो ये circuit ही चला जाता, but वो ऐसा नहीं होगा because उसका melting point is too high. And plus उसमें क्या किया जाता है, एक और precaution ये भी लिया जाता है कि they fill the bulbs with nitrogen, so that अंदर उसका oxidation ना हो जाए, burn होना start ना हो air में, because if you are taking the temperatures too high, or if you are passing current for a very long time, there is a chance that the substance may start reacting with the atmospheric oxygen. But वो वैसा नहीं होने देगा because nitrogen gas is filled up in it. ठीक है, so what does it do is it will help to prevent the oxidation, because nitrogen is the least reactive substance which is present in the atmosphere. वो ज़्यादा react नहीं करता है. Oxygen is active component, so it reacts. Nitrogen react नहीं करेगा. Okay. Other applications are also in your, let's say, geysers, toasters. उन सब में we make the use of alloys so that the heating effect produced is more. Okay. Now, while using this, using the devices, we have to take care, because if you pass the current for a long period of time, what will happen is they will get heated up more. वो पुराने जमाने में वो बहुत बड़ा प्रॉब्लम कर रहा था कि ये डिवाइस हीट अप हो जाते थे and you did not have any mechanism to control it. Okay, So now for precaution purpose, what we do is we make the use of uh, we make the use of a device that is called as fuse device. Okay. Now what is the purpose of a fuse? Fuse is nothing but a device which only allows a certain amount of current to pass through it, only a limited current to pass through it. ओके अब फ्यूज अगर तुम देखोगे ना तो वो प्रेजेंट कहाँ पे होता है, मतलब लेट्स से दिस इज योर इलेक्ट्रिक आयन, अगर ये तुम्हारा इलेक्ट्रिक आयन है सपोज, लेट्स से दिस इज योर इलेक्ट्रिक आयन, ठीक है, इसके अंदर देयर इज अ स्मॉल डिवाइस कुछ ऐसा, एंड जस्ट मेक इट विद सम अदर कलर, अंदर एक छोटा सा डिवाइस रहेगा, एकदम छोटा सा डिवाइस, दिस इज नथिंग बट कॉल्ड एज योर फ्यूज. ओके नाउ व्हाट इज द पर्पस ऑफ दिस फ्यूज इज, ये कुछ ऐसा होता है. फ्यूज हैज अंदर एक वायर, this fuse is let's say made up of alloy, or maybe even of aluminium, or maybe even of copper. ठीक है, मतलब ये जो अंदर का वायर है ये वाला पार्ट, it is either made up of alloy or aluminium also. And this fuse has a certain rating. Rating का मतलब, let's say if I say that this fuse has a rating of 5 amperes. ठीक है, तो what does this fuse do is it will only allow a current of 5 amperes to flow through it. अगर current का value 5 amperes से ज्यादा हो गया, then the wire starts melting. And always remember, the fuse is connected in series with the electric iron. मतलब ये समझो मेरा अगर इलेक्ट्रिक आयन है, if this is my electric iron, तो उसका कुछ अंदर रेजिस्टेंस होगा, उसके पहले आई हैव दिस फ्यूज, मतलब करंट कम्स इन फ्रॉम हियर, passes through the fuse first, and then it passes through the heating coil. Okay, so now what is the advantage is, if the heating coil heats up more, maximum the current that can pass through the fuse wire is nothing but 5 amperes. उससे ज़्यादा current flow नहीं हो सकता, because if the current exceeds the 5 ampere value, the fuse melts, and once the fuse melts, this is gone. So now no current passes through the electric iron. ठीक है, getting this part? So this is the application of fuse. This we will see more in the second chapter of how exactly fuses are used in our domestic circuits. उसका function is to only allow a limited current to pass through it. Okay, now for our households there are few values that you have to remember, और इस बार इसके ऊपर question भी आया था exam में. What all values of fuses are available, ठीक है, for the domestic circuits. अब domestic circuits में ना potential difference जो है, it is about 220 volts that we get in our houses. We will see this in the next chapter also, but I'm just giving you all the examples. The potential difference that is available is 220 volts, and for different devices we have fuse ratings of 1 amperes, 2 amperes, 3 amperes, 5 amperes and 10 amperes. ठीक है, ये सब फ्यूज रेटिंग्स मेरे पास अवेलेबल है फॉर डिफरेंट डिवाइसेस. मतलब अगर मुझे गीजर्स या एसी चलाना है तो आई मे हैव टू गो इन फॉर 10 amperes. फॉर नॉर्मल डिवाइसेस इवन 1 ampere फ्यूज इज ओके. ठीक है, नाउ after seeing all this, let's go to the last part of the chapter, that is called as power. एंड इसका कैलकुलेशन हमने लास्ट ईयर भी किया था और ये तुमको अभी भी करना है. फर्स्ट लेट अस सी व्हाट डू वी डिफाइन पावर. पावर इज नथिंग बट द कैपेसिटी टू डू वर्क. सो व्हाट इज द फॉर्मूला फॉर पावर? पावर इज नथिंग बट इक्वल्स टू वर्क अपॉन टाइम. ये हमको पता है, ये लास्ट ईयर भी था, ठीक है. We had seen two persons, one of age 20, one of age 60. So the one with age 20 will have more power because he can do the same work in lesser time. Now in current electricity, why will this work done be used? जो मैंने अगले स्लाइड में बताया था, work done to move a charge from one point to another point. Okay, so here we have to make the use of it to move a charge from one point to another point in the circuit. So this work is again nothing but energy only. Barabar? Now let us define work, or sorry, potential difference का formula हमको पता था. V was equals to W upon Q. W is equals to V into Q. So in place of W, substitute V into Q upon T. And I know that I is nothing but equals to Q upon T. So what can I write Q upon T as? Q upon T को I can write it as nothing but my I. So power is nothing but equals to V into I. ठीक है. और for remembrance purposes, how do we remember this is VIP. जैसे वो वीर हमने किया था, this is nothing but VIP. Very important person. So the formula for power is nothing but equals to V into I. This is one formula. You can also write power as, power में V into I की जगह पे I can be written as V upon R by Ohm's law. V is equals to IR. Okay, so I can say that I is equals to V by R. So I substitute this value in Vi, so I get the value as P is nothing but equals to V square by R. Okay, now in this formula, if I substitute the value of I get the formula as P is equals to V square R. Okay, we will try to use this whenever we have parallel circuits because the potential difference remains the same. So I've got the answer in terms of V. And sometimes in series circuit, we can make the use of this formula also. That is, V power is equals to V into I. So I can say that V is nothing but equals to IR. I can substitute the value of V also. So I can say that power is equals to I into R multiplied by I. So power is nothing but equals to I into I is nothing but I square. So this is I square R. So the three very important formulas of uh, power are as follows. One, VIP. So power is VI. Second formula, power is equals to V square by R. And power is also equals to I square into R. Okay, when we do the numericals, which formula to apply where, I will give you all the hints accordingly. In series circuit, many of the times we will have to use this formula because the current in the entire circuit remains the same. And for parallel circuits, we may prefer this formula. Every time it may not happen, it depends upon the question that is given. And power is equals to V into I. Okay, with this we finish off with all the theory which is there in this particular chapter.